Okay, so as promised, I said I would prove to you in the next video why these statements, if you times two individual surds together, you get one big surd with your two numbers times together. Why is that the case? And similarly, right, if you divide two individual surds, why do you get one big surd with your two numbers being divided by each other? Now, I always think with maths, it is really useful to understand where things come from, but this is a little bit more complex, and it's not something that you need to know. So if you're interested in understanding where this comes from, I would definitely keep watching. If you think this might confuse you a little bit, perhaps I would move on. But it's nothing that you can't do, but I don't want to confuse you if you're new to the topic of surds. Anyway, if you want to find out where this comes from, I would definitely keep watching. So let's prove the first statement, which is this, that root a times by the root b is equal to the root a times by b underneath one singular surd. And it might seem a little bit strange, but before I prove this, I want to go and prove a separate statement, because that's going to be useful later on. The statement I want to prove to myself is this, is that the root of, let's go and say p squared times by the root of q squared is the same thing as the square root of p squared times by q squared. And you might see, well, what's that got to do with this up here? You'll see why it's very useful later. Now, if I go consider this first part here, the square root of p squared, we know the square root we can write in terms of indices as to the power of a half. So I've got p squared to the power of 1 over 2. And if I write it like that, I write it as p squared to the power, p squared to the power of 1 over 2, okay? And I do the same thing with the q squared part. I'm rooting it, so it's going to be q squared to the power of 1 over 2, okay? That's my left-hand side. This bit over here, okay, p squared times by the q squared, right, we can write this a little bit differently because p squared times by q squared is the same thing as writing p times by q all squared. We know that from further down, from earlier on in our maths careers. So we can rewrite this part as brackets p times by q all squared. And then, of course, we've still got that square root sign there, square rooting the whole thing. So we can go and put the whole thing to the power of 1 over 2, because it means the same thing, just written in index form. And then now, this stuff here, okay, p squared to the power of a half, and then this, these are just using your third law of indices, which is your power law, which is we can go and times the exponents together. So we can just go and times all of these exponents together, and they're going to simplify out really nicely. Okay, to give us, well, 2 times by half is just 1, so it's going to give you p to the power of 1. Times by, similarly, it's going to be p times by q is equal to, and of course, over here, 2 times by half gives you 1 again, so you're just going to be left with p times by q. So you can really, really clearly see, okay, that I've proven that the left-hand side of this statement, right, is equal to p times by q, which is exactly the same thing as the right-hand side of my statement, which gives you p times q. So I can see, right, I've proven that my left-hand side is the same thing as my right-hand side. And now I can use this, okay, I can use this fact to help me prove this up here. Okay, so let's scroll down a little bit. Right, I'm gonna use a different color pen now. I'm now gonna go and define some new variables. Right, I'm gonna go and let p be equal to the square root of a, and that q is equal to the square root of b. And I'm going to put these things into this statement up here to help me prove this up here. So the first bit, right, if p is equal to root a, I put it into this, and we're going to be getting root a squared square rooted. Let's write it out, it's a bit more clear to see. So I've got p squared, well, p is equal to root a, so it's going to be root a squared, okay, and then all of that is still being square rooted up here. So it's all being square rooted. And then timesing that by q squared, well, q is equal to root b, so it's going to be root b, but it's q squared, so root b squared, and again, it's all being square rooted. And that is equal to my right-hand side, okay, which is going to be p squared times by q squared. Let's look at that part first. So p squared again, I can go and write p squared is going to be, well, p is equal to root a, so it's going to be root a squared times by q squared, well, q is equal to root b, so it's going to be root b squared, and then of course I'm square rooting the whole shebang, so the whole thing here is being square rooted. Okay, good. I'm now going to go And right, this part here, root A, okay, root A, remember, means to the power of a half. So I'm going to write this a little bit differently. I'm going to keep this root the same, keep this root the same, and keep this root the same as a third, and say I've got the square root, okay, root A squared I can write as A to the power of 1 over 2. So I've just changed this root sign to a to the half, and if I'm squaring it, okay, it's going to be a to the half squared times by, again, I've got the big square root sign. I've then got root B I can write as B to the power of 1 over 2, and I'm squaring that, okay, and that's equal to my right hand side. Again, I'm going to go and keep this big root sign the same and write it as the square root of root A squared. I can go and write again as A to the power of 1 over 2, all squared, times by B to the power of 1 over 2, all squared. Oh, sorry, my pen pad is in the way. Sorry. That's not good. Sorry. Okay, good. Sorry, all squared. There we go. We're almost there, as you might be seeing, because, right, these laws of indices, right, these powers are going to times together, and they're all going to cancel to 1, which is really useful. So I can go and say that the first part, okay, is going to go to, right, half times by 2 will give you 1. That's going to be a to the power of 1 square rooted. So I can go and say I've got the square root of A times by, and then similarly the same thing for the next part, square root of B is all equal to, and then over here again, this times by this will give you 1. So it's going to give you A times by, half times by 2 is 1. So it's going to give you A times by B. And of course, I still got that big square root sign there. So it's going to be all over this. And I've proven, okay, beautifully, this statement up here. Okay, I've proven this kind of by proving this first of all, but eventually, right, I did get there. So there we go. And let's go and put this in a bit of a box, just so we can highlight it. Right, I've proven this statement, which is really nice. Okay, and if you understand that, fantastic, because it's always just really nice to know where things come from. You can just learn them, you know, that's fine, and apply them. Understanding stuff is really nice. Okay, let's now go and prove the second statement, right, which is, if you can do the left-hand statement, it's a very, very similar idea to this, right, with this over here. I'm going to begin, again, by proving something a little bit different. Okay, I'm going to begin by proving that the root of p squared over the root of q squared is equal to the whole square root of p squared over q squared. So a very similar idea to what I did on my left-hand side. Okay, and again, I'm going to go and write now these parts, these root signs, in terms of indices. So I can go and write, I've got p squared to the power of 1 over 2 over q squared to the power of 1 over 2. So the rooting is the same thing as to the power of a half, being equal to, I've then got this bit down here, okay, p squared over q squared, right, just to make a bit of a note of that, we know that p squared over q squared can be written as p over q all squared. They mean exactly the same thing. Okay, so I can write this as p over q all being squared, okay, and then of course I'm square rooting the whole shebang, so I can go and put all of this here to the power of 1 over 2. And then laws of indices, right, power rule, we can go and times up all of these indexes together, okay, which is going to cancel out nicely to give us, well, 2 times by half again gives you 1, so it gives you p over q is equal to, and then those powers cancel again to give you again p over q. So again, if I zoom out a little bit, right, we can see that my left-hand side of this statement gives you p over q, which is exactly the same thing as the right-hand side of my statement, which again gives you p over q, which is nice. And then what we're going to go and do is do a very, very similar thing, and let's just put a bit of a dividing line up here so we don't get confused with the other stuff. Okay, very similar idea to what I did before. Okay, let's go and let p equal to root a, so p being equal to root a, and q being equal to root b, and let's put it into this statement to prove the statement above is indeed true. So we're going to put root a into this and root b into this statement. Okay, it might get a little bit cramped. We should be okay. So let's go do this. So we've got root p squared. So we've got the square root of, and now p is equal to root a, so it's going to be root a, all being squared, okay, over, I have to go down a little bit. Oh, I want to keep it all in one shot, sorry. Over the square root of q squared, well, q is equal to root b, so over root b squared, and that is equal to the full square root p squared, well, p is equal to root a again, so it's going to be root a squared over root b squared. Okay, and then similarly, okay, we can write these parts here in terms of indexes. I'm going to keep this root sign the same, this the same, and this the same, like over here, and say I've got the square root of a to the power of 1 over 2, all being squared over the square root of b to the power of 1 over 2, all being squared. Okay, so I've just changed the smaller root sign into indexes, kept the bigger one the same. And over here, that's going to write the big square root still, and then similarly do the same thing and write root a is a to the half, and then of course we are squaring it over b to the half, and again we are squaring it. And what happens here again, of course we can times these indexes together, law of indices, okay, and we're going to be very close now to what we want, and these are going to give you 1, so it's going to give you just the square root of a over the square root of b is equal to the square root, and over here, right, again, these will give you just 1, so they're going to cancel. Same thing with b, to give you just the big square root sign, give you a over b. So I've proven, right, that if you divide two individual surds, you can write it as one big surd. There we go. Okay, so it got a little bit messy towards the end, didn't it? But there we go. And if I zoom out, let's try and get it all into one shot. Oh, it's a bit small, isn't it? It's going to be very small, particularly if you're watching on your phone or whatever. But, okay, right, there is the proof. Quite a long proof, but hopefully quite useful. Again, right, if that is massively confusing you, to be honest, all you need to know is these two facts up here, okay? But this is just proving to us why that is true. Okay, thank you.